Hello guys,
I'm Jasper.
I'm Cookie.
Today we will be helping you guys to understand the basic law of logarithms.
10 power 1 equals to 10 and 10 power 2 is equal to 100. Simple, right? But what should we do when we want to find the value of power that gives 10 equal to 40?
If we want to get a more precise value of x, we must employ the principle of logarithm to the equation. First, you bring the power of x down to become just an x. Then, you write a log to the left side of 40, and after that, you move 10 to the other side and let it be a subscript of log. Using a calculator, you should get the value of x about 1.6.
By using the question that we just did, we can create a general formula, which is when y is equal to a to the power of x, then the value of x is equal to log base a of y. This general formula can be applied to many equations. However, the requirement is that the value of a and y must be above 0, and a must not equal to 1. Any number that fails to meet this requirement will be undefined.
Next thing that we're going to learn about is special abbreviations for a log that has a base of 10 or e. When we are talking about common logarithms, we are referring to a log that has base 10. Some textbooks might abbreviate log base 10 as LG. For natural logarithms, we are dealing with a special base called e. In some textbooks, you might encounter this natural log 50, which is just an abbreviation form of log base e of 50.
Now, let's get on to laws of logarithm. The first law is change of base law.
Let me give you guys an example of this law. Log base 3 of 8 is equal to log base c of 8 over log base c of 3. C can be any value above 0 and not equal to 1. It will still yield the same answer. From this example, we can create a general formula, which is a log base a of b equal to log base c of b over log base c of a.
For example, if the question asks for log base 7 of 5 times with log base 5 of 9 times with log base 9 of 7, using general formula and base c equal to common log, we will get common log of 5 over common log of 7 times common log of 9 over common log of 5 times common log of 7 over common log of 9. After we cancel everything out, we will get the answer of 1.
That was pretty easy, wasn't it? Let's move on to the next law, which is the product law.
If we got log base 2 of a product of 3 and 5, what should we do? Using the product law, we will get log base 2 of 3 plus log base 2 of 5, and then use calculator to solve for log. Let me give you another example. Log base 4 of the product of x and x plus 3. Again, using the product law, we will get log base 4 of x plus log base 4 of x plus 3.
From these equations, we can create the general formula for this law, which is log base a of x times y equal to log base a of x plus log base a of y.
Please be noted that log base 4 of x plus 3 is not equal to log base 4 of x plus log base 4 of 3.
I see. That's something you need to be careful with, isn't it? Let us proceed to the next law, quotient law. If we have log base 3 of 7 over 2, it is equal to a log base 2 of numerator, which is 7, subtracted with a log base 2 of denominator, which is 2. Let's give another example with a variable. If we have log base 2 of x plus 1 over x, it is equal to log base 2 of x plus 1, subtracted with log base 2 of x.
It's quite the opposite of the second law, right? Now, let's make general formula for the third law too. We will get log base a of x over y is equal to log base a of x subtracted with log base a of y.
Please be noted that if we have log base 3 of 7 over log base 3 of 2, it is not equal to log base 3 of 7 over 2.
Last but not least, the power law.
If the question asks for log base 3 of 2 to the power of 5, how can we simplify it? By using the power law, we can bring the power down to times with the log. Let's give you another example. If we have log base 3 of x to the power of negative 3, then using the power law, we will get negative 3 times log base 3 of x.
With these examples, we can form a general formula, which is log base a of x to the power of r is equal to r times log base a of x.
Please be noted that if you see log base a of x to the power of r like this, it means only x itself is powered, not both log and x.
Now that we know all of the laws already, let's proceed to the last topic of today, which is logarithmic equation.
If log base a of m is equal to log a of n, then we can conclude that m is equal to n.
To make this idea seems more clear to you, let us do an example using this principle. If we have log base 3 of x plus 1 equal to log base 3 of 4, we can simply conclude that x plus 1 is equal to 4 and get rid of log. Eventually, we get a value of x equal to 3. Now, let's do some questions together. The mass m grams of a radioactive substance present at time t days after first being observed is given by the formula m equal to 24e, while e have the power of negative 0.02 t. Find A. The value of m where t is equal to 3. B. The value of t when the mass is half of its value at t equal to 0. How was the question? Were you guys able to do it? Now, here's the solution. For A, you just have to copy the formula they give us first, which is m equal to 24e to the power of negative 0.02 t. Then you substitute t equals to 3. Then use your calculator to calculate it out. Then you will get m will be approximately about 13.2. For B, first we substitute t equal to 0 into the formula. Then we will get m equal to 24. Then we divided it by 2 and we will get m equal to 12. After that, we substitute m equal to 12 into the formula. Then we will get 12 equal to 24e to the power of negative 0.02 t. After that, we divided it by 24 to the two sides of the equation, and we will get 1 over 2 equal to e to the power of negative 0.02 t. Then we will multiply the natural log to the both sides of the equation. Then we will use the power law to bring the power down and times it with the log, and we will get ln times 1 over 2 is equal to negative 0.02 t times with ln e. After that, use the calculator to calculate the t out, and we will get t is approximately about 34.7.
Thank you for listening to our presentation, guys.
We hope that this video will help you have more understanding on logarithms. Bye!